Okay, the calculations are straightforward. Let's see if I've got them right. Remember, we corrected this one from my original video and the short correction video. Using the 0.5, 0.87, the green vector here, we transform it by multiplying by the matrix. And 0.8 times 0.5 is 0.4, negative 0.6 times 0.87 is negative 0.522. 0.4 minus 0.522 is negative 0.122, unless I've done something really bad. If I have, I'm sure you're catching it. Okay, and 0.6 times 0.5 is 0.3. 0.8 times 0.87 is 0.696. Add 0.3 to 0.696, you get 0.996. Now the calculation here is quite straightforward. I think I've got it right. Over here the calculations are actually quite a bit easier. So the 2, 0 times 0, negative 3, multiplied by the 1, 0, well, that gives us 2 here, and it doesn't give us 0, it gives us negative 3. I'm a little tendency to write things down carelessly here, and there will be days when I do that, so keep an eye on it. Okay, and I think these are correct. 2 times 0.87 is 1.74, negative 3 times 0.8 times 0.5 is negative 1.5, and 2 times 0.5 is 1, negative 3 times 0.87 is 2.61. So I think the rest of these are correct. And if they aren't, well, hopefully you've done the calculations and you've already corrected me. Now, I'm going to draw 2 sets of coordinate axes here. One of them is going to contain these 4 vectors. So the transformation T1 takes these 4 vectors to these 4 vectors. We're going to draw these 4 vectors and see just what happened to these vectors. Okay, and then down here, we'll sketch another set of coordinate axes. And this will show us what T2 does to these 4 vectors. Okay, so first of all, our purple vector here is 0.8, 0.6. Now, as it turns out, and as you can easily verify, each of these vectors has a magnitude of approximately 1. That is, if you take the distance from the origin out to the tip of each vector, which is just the origin, for example, out to the point, 0.87, 0.5, use the Pythagorean theorem, you're going to get something very close to 1. Okay, now 0.87 is a round off of an irrational number. 0.866 would be closer. But it's an irrational number, so you wouldn't get exactly 1 if you applied the Pythagorean theorem, but you expect to be plus or minus 0.01 within plus or minus 0.01 of 1 when you calculate the length of that vector. Just a little aside. Okay, and if you didn't understand it, don't worry, we'll do it slowly. So each of these vectors has a length of 1, so I'm going to go ahead and just draw my best attempt at a circle and assume that the radius of this circle is 1. And then I want to draw the vector 0.8, 0.6. Well, let's see, 0.8 is here on the x-axis, 0.6 would be about here. If I do 0.8, 0.6, it looks like that vector's on this circle because it looks like, well, 0.8, 0.6 does have a magnitude of 1, doesn't it? And you can use the Pythagorean theorem and verify that. Okay, well, that's, again, just an aside. We're trying to look at geometrically what happens here. 0.396 is pretty close to 0.4, so let's just say, okay, 0.4 ought to be about here, and 0.922 is way up here, and very plausible that this vector has a magnitude of 1, or magnitude very close to 1. Okay, this vector, negative 0.122 to 0.966, well, negative 0.122 is pretty close to 0 on a scale from 0 to negative 1. And 0.996 is practically 1, so it's again very plausible that this vector, the transformed vector from here, goes to here. And then finally, it looks like this vector goes to negative 0.6, 0.8, which is again a vector of magnitude 1 or length 1. Okay, so what does it look like has happened here? Well, it appears that these vectors got maybe rotated here. Now the way I've drawn it, it looks like these two vectors are a little closer than these two and these two. That could be just because I didn't draw it very accurately. It could be because they really are closer if you do the calculations correctly. Now you know enough trigonometry to figure out what the angles of all these vectors are, so you can verify. These are all 30 degrees apart. So you could take these components, do the arctangent of the y component over the x component, and figure out the angles and see if they really are 30 degrees apart. If they are, then it would appear that this is a matrix that rotates everything. Rotates this vector from here through this angle, rotates this vector through the same angle, and this one and this one. Okay? And you can check out, if you're inclined and if you have time, whether that's so or not. Again, if you don't have time to do that, well, just understand that there are such things as rotation matrices, and maybe this is one, maybe it isn't. But if it is, then it's a good illustration, okay? Now, this transformation over here, let's see what it does. And let's just kind of split this up. We'll do another video to address that transformation.